We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Namaskar friends. In this session, we will learn about the subject Basic Electrical Engineering, Unit 3 Transformer. The major topic is single phase transformers, working and comparison. The working principle of transformer. As seen from the figure, the main principle of operation of transformer is mutual inductance between two circuits which is linked by a common magnetic flux. A basic transformer consists of two coils that are electrically separate and inductive, but are magnetically linked through a path of reluctance. The transformer has two windings, primary and secondary. Primary winding is connected with input supply side and the secondary winding is connected with output load side. आप फिगर में देख रहे हैं कि लेफ्ट हैंड साइड में एक वाइंडिंग बना हुआ है जो वाइंडिंग सप्लाई के साथ कनेक्ट होता है, दैट्स वाई इट इज नोन एज प्राइमरी वाइंडिंग. राइट हैंड साइड में एक दूसरा वाइंडिंग दिया हुआ है जो कि लोड के साथ कनेक्ट होता है, दैट्स वाई इट इज नोन एज सेकेंडरी वाइंडिंग. और ये दोनों वाइंडिंग के बीच में एक रेक्टेंगुलर जैसा शेप बना हुआ है, दैट इज नोन एज द ट्रांसफॉर्मर कोर. ये ट्रांसफॉर्मर कोर प्राइमरी वाइंडिंग में से सेकेंडरी वाइंडिंग में फ्लक्स को एक पाथ बना के म्यूचुअली ट्रांसफर करता है और दोनों वाइंडिंग के बीच पावर का जो ट्रांसफॉर्मर हो रहा है वो इलेक्ट्रोमैग्नेटिकल फॉर्म में हो रहा है. यहाँ पर दोनों वाइंडिंग से वो इलेक्ट्रिकली आइसोलेटेड है, दैट इज नॉट कनेक्टेड डायरेक्टली टू इलेक्ट्रिकली, लेकिन मैग्नेटिकली कपल्ड है. The core laminations are joined in the form of strips. In between the strips, you can see that there are some narrow gaps right through the cross section of the core. These staggered joints are said to be laminated. Both the coils have high mutual inductance. A mutual electromotive force is induced in the transformer from the alternating flux that is set up in the laminated core due to the coil that is connected to a source of alternating voltage. Most of the alternating flux developed by this coil is linked with the other coil and hence produces the mutual induced electromotive force, that means induced EMF. So the produced EMF can be explained with the help of Faraday's law of electromagnetic induction as E is equal to minus n d phi by dt, where E is the induced EMF, capital N is the number of turns of the winding, d by dt of phi, that means the rate and change of flux, that means instantaneous value of the flux, and minus sign is for the Lenz's law. If the secondary coil circuit is closed, a current flows in it and thus electrical energy is transferred magnetically from the first, that means primary coil, to the secondary coil. In short, the transformer carries the operation as shown below. Transfer of electric power from one circuit to another, transfer of electric power without any change in frequency, transfer with the principle of electromagnetic induction. The two electrical circuits are linked by mutual induction. EMF equation. When a AC voltage is applied to the primary winding of a transformer, alternating flux set up in the iron core of the transformer. This alternating flux links with both primary and secondary winding. The function of a flux is a sine function. The rate of change of flux with respect to time is derived mathematically. Let phi m be the maximum value of flux in Weber, small f be the supply frequency in Hertz, capital N1 is the number of turns in the primary winding, capital N2 is the number of turns in the secondary winding, and phi is the flux per turn in Weber. Now consider this waveform of sinusoidal. As shown is in the figure that the flux changes from positive to negative in a half cycle of 1 by 2f second. By Faraday's law of electromagnetic induction, let E1 is the EMF induced in the primary winding. Then E1 is equal to minus n d phi by dt. Since it is due to AC supply, so the induced EMF lags the flux by 90 degree. Maximum value of induced EMF E1 max is equal to N1 omega phi m, but omega is equal to 2 pi f. Hence E1 max is equal to 2 pi f N1 phi m. The RMS value is given by E1, that means fundamental, is equal to maximum upon root 2. That's why E1 max upon root 2. Putting the value of E1 max in the above equation, we get E1 is equal to root 2 pi f N1 into pi m, where root 2 into pi is nothing but the 4.44. So for E1 is equal to 4.44 f N1 phi m. Similarly, we get E2 is equal to 4.44 f N2 phi m. Now let us compare ideal transformer and practical transformer. आइडियल ट्रांसफॉर्मर मतलब जिसको हम देख नहीं सकते हैं, जो वास्तव में यूज नहीं हो सकता है, वास्तव में उसका कोई फिजिकल एग्जिस्टेंस नहीं होता है, वो सिर्फ इमेजनरी है। जैसे कि स्वप्न में हम सोचते कि ऐसा है वैसा है वैसा है, लेकिन फिजिकल वर्ल्ड में वो ऐसा जरूरी नहीं है, जो सिर्फ विजुअली नहीं है, सिर्फ इमेजनरी है। दैट इज कॉल्ड आइडियल ट्रांसफॉर्मर। सो ideal transformer has 100% efficiency, but practical transformer has less than 100% efficiency. The overall losses is 0 in ideal transformer, but there are some overall losses in practical transformer. In ideal transformer, purely inductive material used, but in practical transformer, purely inductive material is not used. In ideal transformer, it has no I square R losses, but practical transformer has some I square R losses. In ideal transformer, it has no iron losses, but practical transformer has iron losses. In ideal transformer, it has no ohmic resistance drop, that is IR drop, but in practical transformer, it has some IR drop. In ideal transformer, it has no magnetic leakage, but in practical transformer, there are some magnetic leakages. In ideal transformer, conditions are ideal, but in real or actual or practical transformer, there is condition of practical. There is no any ideal condition. Ideal transformer, it is not used in practical condition because उसका कोई existence ही नहीं है. But practical transformer is used in actual applications in real life. So practical transformer is the real transformer or actual transformer. पहले ही कहा था आइडियल ट्रांसफॉर्मर इट इज वर्चुअली और इमेजिनरी, बट प्रैक्टिकल ट्रांसफॉर्मर इज रियल. नाउ लेट अस अंडरस्टैंड ऑटो ट्रांसफॉर्मर. As from this figure, auto transformer is kind of electrical transformer where primary and secondary shares same common single winding. So basically it is a one winding transformer. In auto transformer, one single winding is used as a primary winding as well as secondary winding. But in a two windings transformer, two different windings are used for primary and secondary purpose. वो हमने पहले आगे देखा. A diagram of auto transformer is shown above. The winding AB of total turns N1 is considered as primary winding. This winding is tapped from point C and the portion BC is considered as secondary. Let us assume the number of turns in between points B and C, that is N2. If V1 voltage is applied across the winding, that means in between A and C, so voltage per turn in this winding is V1 divided by N1. Hence, the voltage across the portion BC of the winding will be V1 divided by N1 multiplied by N2, and from the above, this voltage is V2. Hence, V1 by N1 multiplied by N2 is equal to V2. So V2 by V1 is equal to N2 by N1, that is constant, and that may be designated by capital K. Hence, the voltage across the portion BC of the winding will be, as BC portion of the winding is considered as secondary, it can easily be understood that value of constant K is nothing but turns ratio or voltage ratio of that auto transformer. So V2 by V1 or N2 by N1 is known as the voltage ratio or turns ratio of the auto transformer. When load is connected between secondary terminals, that means between B and C, load current I2 starts flowing. The current in the secondary winding or common winding is the difference of I2 and I1. Some applications of the auto transformer. इसकी वेल नोन एप्लीकेशन है, हम लेबोरेटरी में यूज करते हैं. Compensating voltage drops by boosting supply voltage in distribution systems. That means as a voltage booster. Auto transformers with a number of tappings are used for the starting, induction and synchronous motors. Auto transformer is used as variac in laboratory or where continuous variable or broad ranges are required. The auto transformer is used as balance coil to give a neutral in a 3-wire AC distribution system. So the main difference between a 2-winding transformer and auto transformer is 2-winding transformer में दो अलग अलग वाइंडिंग है और दोनों इलेक्ट्रिकली सेपरेट है, लेकिन उसके बीच में जो कनेक्शन है वो मैग्नेटिकली कपल्ड है. ऑटो ट्रांसफॉर्मर है उसमें सिंगल वाइंडिंग है, एक ही वाइंडिंग है, उसका आधा पार्ट प्राइमरी बनेगा और आधा पार्ट है सेकेंडरी के पे काम करेगा. सो सिंगल वाइंडिंग है, इलेक्ट्रिकली आइसोलेट नहीं है. तो 2 वाइंडिंग ट्रांसफॉर्मर के कंपैरिजन में ऑटो ट्रांसफॉर्मर में शॉर्ट सर्किट, मेंटेनेंस जैसा प्रॉब्लम ज्यादा रहते हैं. If you have any query regarding these topics, you can mail us to bhavin.kanani@darshan.ac.in. For more details, you can visit our website www.darshan.ac.in.